Sorry for a trip. So we can continue now. Is, as we said, the T is the driving force, and then the mg sign is opposite on plus the resistance. So the equation becomes T minus mag sine theta plus fa is MAA. And in a vertical direction is NA minus MAG cosine theta equals 0. And we know that FA is mu NA and is mu MAG cosine theta if we calculate from here. So this becomes just simple math. We can put this there and calculate the acceleration or the tension in the rope. Now let's assume B is the system. So I move on. This was A. Now we don't concern about it. We can say this one is MB and this is C, and then the F is acting on B, and this is my system. So again, here you got MBG cosine theta and MBG sine theta. Then you got mcg cosine theta, the part of the mass of C pressing the surface of B, and also you got T, and there is a force normal from the surface acting at the point of contact. This is NB. So you can see, for example, mcg sine theta, it's not gonna be a force acting on B, basically. So it's not considered as the force as a force for the system B. Also, because this movement is toward this direction, there is a frictional force, which we call it this way, for example, just to be separated from the rest, but anywhere between the surface of B and the inclined plane. This is FB, opposite direction of motion, and then C wants to stay when B moves up. So basically B is moving up and C is on the surface, so C pushing A toward against the direction. So the friction also here is FC to B. So your equation of motion, considering all these forces, is F minus FB, which is the friction from the inclined plane, plus FC to B, the friction between C and B, is outside the system because system is B, plus MBG sine theta, which is a part of the force acting according to the mass of the bead, and the tension in the row. These all become MBA. And in the normal direction, NB minus MBG cosine theta plus MCG cosine theta is 0. That becomes the forces which acting on vertical direction when the system is considered B. Now let's also go one step again and consider C as the system and see what is the condition. if we put C as the system, and you see not much complicated now, we can understand it. And this is B, this is A, this is C, and this one is my system. F acting on B, but because system is C, so that is not the force acting on the system. The force acting on the system is the friction between C and B. So B is moving up, he wants to pull the mass C with itself. So there is a frictional force F B to C, which is the same as the before example, which is the same as C to B here. But according to third law of Newton, this acts from C to B, this acts from B to C, although they are the same magnitude, but two different points of action, therefore they don't neutralize each other, they don't cancel each other. There is another force of mass in CG cosine theta and in CG sine theta. Also, the tension is not considered for this system because it's not connected to C. So this becomes all the forces that you have, and friction now becomes a driving force. Minus mcg sine theta is mca. There is a reaction force also mc here, which is, you can say, B to C, from the surface of B acting upward. So N B to C minus mcg cosine theta is 0. And we know if B to C is mu N B to C, which is equal to this, so mu mcg cosine theta. And you can do the math, and based on the parameters of the system, we can calculate the acceleration, we can calculate the tension, we can calculate the frictional force. Sometimes in many questions, actually, they ignore the friction, so it becomes like no friction. If there is no friction between C and B, in practical, C is not gonna move upward because there is no frictional force to pull it, and it will just slide down in this direction.